Hello everybody, welcome back to While True Learn. We're going to continue where we left off last time. The first task for this episode is Dictatorship. Greetings, this is the only state internet provider of a small country. We have rather suboptimal code to track our people's activities. Unfortunately, we cannot allow you to change the actual code, but we have several new servers purchased on a garage sale. Parallel the calculations, this will help our tyranny prosper. Okay, should I even do this then? I guess so, it's part of the game and it's, in the middle branch and I can't proceed without doing this. So, Cat Hub. These are Cat Hub repositories. They store previously made schemes and allow switching between them when required. You can choose a version of the scheme which will be used as custom node. Okay. I guess this is just like a draft where I can, I guess I can switch between different drafts so I don't have to delete everything and try this again, okay? So, just the standard, sort out all the reds. And then we have 30 output. Expert system takes 1 second. We need 30 of them. So out of 3 colors, we'll probably need to process about 90. We need about 90 seconds. And we have 27 seconds available, so we need at least 4 of these in parallel to be able to make that time. So 1, 2, 3, 4. Connect all the balancers. Okay, and then we'll trash everything that's not red. And send all the red to our output. Okay, that should be okay. Cool. Next one, we have a startup, Tatari. Good day, we are inviting you to join our hacker startup. We write cheats and guides for different games, but now we would like to try making something real cool. We need a program that will play and win an Arkanoid instead of the player. We know that you know a lot about machine learning, so we are inviting you to participate in our startup. 1200, okay, that's not bad. Okay, this is sorting red and blue. And we can do balancer. Oh, right. For a startup, we don't have a time limit here. But the balancer here is going to be a trade-off then, I'm thinking. Because with more balancers, we can process things much faster, but it also costs us more money. So we'll get less money from our startup. On the other hand, if we process things faster, we can serve more customers. So at the end, I think it'll depend on how many customers we get. So we only need as many balancers as is needed to serve all our customers, and there's no point putting more. Okay, okay, we got our basic decision tree. Yeah, so if we want only red and blue and decision tree is still much faster, we should do our two-step thing. Except I'm thinking, okay, which combinations of colors do we want here? And then we're not limited by the number of nodes, so we can do something super redundant, like let's try 4 lanes. I don't know if it'll be too much. Actually, no, let's just try 2 lanes. So we're gonna do, because we need both red and blue individually, I'm thinking something like this. So we're gonna do red and blue, separate the red and blue first, and then of course the red is gonna be mixed with some green, so we're gonna filter the green out, trash it, Same thing here, the blue is going to be mixed with some green, so we'll trash the green. And then red and blue can go to their respective outputs. And then we'll just repeat the same thing here, because we're doing 2 of these in parallel. Let's test. Okay, so they are doing their job. It is working. The only question is it fast enough? So we'll release that. And then we'll look at our, I guess I'll go to the next screen. Yeah, we'll look at our users number, and if it's starting to turn red, then we'll patch it to process faster. Next day, okay, we're still doing good. Getting lots of hype. Our users are increasing though. Alright, we already made back our initial investment. Our users are still increasing. The hype is getting real, okay? Okay, we're making tons of cash. And it doesn't look like we ever hit our limit. So we have been able to serve all our customers with just one parallel. Or one splitter, whatever it's called. The load balancer, yeah. Okay, we're losing customers now. I think it's good enough. Okay, we made some money. Our income is starting to get negative, so we're not going to continue anymore. Cash out. Okay, and we got something in our CBay again, so let's go that. 40,000 now. Okay, we're still a pretty long way there. Nothing new here. Nodes are still locked. We can buy new hardware though. Server US 2000 decreases server cost by 3%. Okay, that's cool. We like that. 256 megabytes RAM increases sockets processing queue by 5. Okay. GVIDIA 250 increases nodes work speed by 3%. Okay, these are all. Provides DLL slots 1. Yeah, there was the DLL feature that I haven't looked at yet. 30 gigabyte HDD. Kel server 3500 decreases server cost by 3% again. And TP Gink router increases data transfer speed by 5%. Okay, looks like that's all we have. Do we have any more cats available? We have one for 12,000. We have just a bit not enough. Okay, this is our. We still have our cat. These are the same cats as before. Don't have anything new. Okay. And then we'll get the raccoon again just for the lulz. Okay, tree. Go back to our tasks. Next one is prediction of elections. Good morning. We're contacting you on behalf of Yahoo's Corp. The president of our partner venture has been dismissed last month and the board of directors is in the process of electing a new one. We need to be able to predict who will win the election so we could make a decision about the future of our partnership with said venture. Make it happen and you will get a handsome reward. Okay, copy paste. Click, hold, and drag your mouse to select modes. Yeah, that seems pretty standard. Okay. Output stream 1 and 3. We want red. And then we have 17 seconds. So, okay, we need a total of 16 red. We have 3 colors, so 16. Right. So we'll need. Is that 3 of them processing in parallel again? Yeah, I don't imagine we'll do that in 7 nodes though. Anyway, red, green, and blue. Okay. So maybe we'll have to. So if we only want the red, we're gonna need 2 decision trees to filter out blue and green. But I'm thinking we can take a shortcut and do red any. That way we only use, oh no, 6 out of 7. Right, because the trash can also counts as a node. Okay, so we're gonna need to finesse this a little bit more. Okay, maybe we can do them slightly differently. So on the top one, we have 2 processing in parallel, but we're gonna do the red any. So it works with 1 layer of decision tree, but it only we only get half of the reds coming out as the output. On this side, we'll try red. Right, we'll try the standard filtering trick to get red, blue, and red, green. So we only have red at the output, and then blue and green we filter out separately to put in the trash. And I guess this is not going to be fast enough, so I'll be observing which one fills up faster. If either one of them fills up within the time limit, then we'll know what to do. If neither one fills up within the time limit, then okay, I guess both routes worked. I was going to say if neither one fills up within the time limit, then we're in trouble. But if both worked, then do I even need this? Because I could just do, you know, copy, paste, and then I could just do this. And the output, I want output to be here. Let's try that. Yeah, that still works. Awesome. Alright, next one. Oh, we have another startup, but there's one underneath too. Automatic Movie Rater. Hello, this message is from the Oscar committee. We want to replace some of our experts with a neural network. Please design a system that could rate movies by their type. Okay, red, green, red, blue. So this is our standard decision tree. All we need to do is green and blue, and then I guess both of them will be, yeah, we'll get a mixture of blue and red, and we'll get a mixture of green and red. However, there is a problem because I'm seeing a lot more green than there are blue, but on the output side we need a lot more on the output that takes blue. So this is not going to be an ideal distribution. So if we test, you can see that this one is actually getting outputs a lot faster than this one. So we will want to do something to put a little bit more output in here. And the only way we can do that is to put some red input into output stream number 3. So we'll have to divide it in some way to kind of balance out the number of outputs that we get. So since we're not... Oh wait, we have a time limit, 25 seconds. Did we make it? No. Yeah, okay, yeah. I got confused for a second because I thought it was a startup and we need to make it faster anyway. But yeah, our time limit is 14 seconds. So we're allowed 4 nodes. That's not bad. We can do a balancer for sure. But I'm thinking, do we even need that? Because without a balancer we can save some money. It's not that important to save money. I have lots of cash already. So we'll put a balancer here, and the other side will just filter out all the green ones. Okay, how about this? No. Okay, that's not gonna work, because this one we can't have any green, and this one we can't have any blue. Okay, let's try. So over here we're effectively dividing all the reds by half. We're splitting the reds into both output channels. What if we filter out the reds? Well, okay, I guess on this side we don't need to filter out the reds. On this side though, we will want to filter out the reds and stick them in the second channel. I'm thinking this is not going to be fast enough either, but we'll get a better balance. Yeah, this one's just slightly slow. So we can improve that again with a balancer. Okay. We're only allowed one more node, so we can't have a setup like this, but we can just do our original idea, the green and blue split. That way, this side will send more outputs to this output stream number 1, but this side, I think the last time we tested it, was sending more outputs to output stream 3, so I'm hoping these two kind of balance out, and they'll help each other complete. Yay, awesome. Accept. Alright, and then we have a startup tracking system. Dissident-friendly tracking system, flourish and prosper, respected programmer. We represent our glorious democratic leader, Admiral General President Ali Babu Petrov Boshi. In his infinite wisdom, he offers or orders you to create a system that would process the recordings of kitchen talks of our beloved government critics, so they would be sent to our country's famous recreational camps. We will pay you a share from each individual who joins our national healthcare program too. One last detail, you must only use technologies developed in our country, as we despise your Western technologies and wish you all slow and painful death. Have a nice day. Okay, they were covering it up pretty good until the last sentence. I was thinking we will pay you a share from each individual who joins our national healthcare program too. That actually doesn't seem that bad unless, national healthcare is another euphemism for something else. Oh wait, this is startup, this is optional, right? So I'm gonna think about whether I really want to do this or not. Let's read an email before that. Machine learning will help the animals. American scientists managed to develop a computer method for detecting the toxicity of chemicals, which is more accurate than animal testing. To create it, they used binary similarity coefficients, and the system itself was trained on information about more than 866,000 dangerous properties of chemicals commonly used in different experiments. Okay, and I'm gonna check. Oh, I think we have enough money to buy the cat now. Yeah, Google glasses. Let's go. Let's look at that. These are VR glasses, cyborg. Okay, now we have a cat wearing Google glasses. Okay. Fine, let's do the startup. In the real world, I wouldn't be doing this, but this is just a game and I want to complete all the levels. Invest 2,000 in the startup. Okay. Okay, only red circles, only green circles. We have a lot to look at. So, do we have sift? We better have sift. Okay, the problem with sift is it's really, really slow. So either we need to balance it, parallelize it a lot, or we move it to the last level. we move it toward the end. We let the faster stages happen first, and then it's going to split into different branches anyway, and then we'll use sift later on. That's another way to do it. Okay, what if we put the decision trees first? Decision tree color, we need specifically red and green. So we can do this, and then more decision trees to filter out the blue, which we don't want. Trash the blue. And then each color can go into their sift, which is still going to be too slow, so I might want to consider splitting that. And we want the circles. Oops, that's the wrong node. Sift, want the circles, and everything else goes in trash. Circles go in here, everything else goes in the trash. Let's test this. I think the decision trees are still gonna get stuck because the sift is so much slower. Oh, no, it looks... Okay, yeah, the sift queue is starting to fill up. We are getting all the correct outputs, it looks like, so the outputs are happy, but the sift queue is getting stuck, and now the decision tree can't send any more items. So, okay. I don't know if we necessarily need to make this any faster, but I will do that anyway. So they now go into balancers. Let's move this over here. And then we're gonna do two sifts in parallel on each lane. I'm hoping, yeah, they should still go to the right outputs. Let's test that. Okay, yeah, now the sift queue is not building up anymore, and everything looks good. Oh, this one's not getting... No, something's wrong. This is just a balancer, it's getting all the red. So all the reds are coming in here. Everything else goes in the trash, yeah? Should be right. Okay, this one's not right. This one's not connected right. This one goes in the green. Yeah, I guess, yeah, I copy pasted that from the red. I see the mistake. This should now work correctly. The outputs are happy. Sift queues are not jamming up. Let it run just a little bit more, just so I can make sure. Okay, that seems fine. Release. Okay. Oh, we have a lot of users that we're not processing. Let's patch that then. Okay, here. Let's move all of that. Copy, paste. I know this is super inefficient, but we are allowed that many nodes, so what does it matter? Alright, I'm gonna put a balancer. And then now we have double the amount of stuff processing. We can process at double the speed. Okay, the question is, are we actually getting more output than last time? Theoretically, yeah, because I doubled the processing, but just from looking at the number of outputs that are arriving, it doesn't actually look like it. But I could be wrong. Let's patch that. Okay, let's go next day. Oh no. We don't have... We have more users. There's still not enough. When and we're making serious negative income. This is bad. Minus 4,000, that's not good. Yeah, we're getting a lot of users, but a lot of them are not getting served. Okay, so I've actually had to reload the old save because the game doesn't let you experiment too much with startups. Once you begin the startup, you have to basically keep going and keep losing money until you go bankrupt, and then it won't let you try again. So yeah, I had to reload an old save and do a bunch of experimentation to find out what works. So the problem with this setup is that it actually uses 2 balancers. And balancers cost extra money, so if we're able to delete one of the balancers, right now it takes 7.52, but if we delete one of the balancers, it takes half as much money. And that was the main issue that was costing us too much money to process. So we're going to reconnect these. We're going to use only 1 sift on each lane now, except now of course we have reduced capacity and we're not processing enough anymore. And so the solution to that is to create a copy of this and then put only 1 balancer up front. So this way, because we have 2 copies of the thing, it achieves the same effect. We're still having 4 lanes of sift going forward, but we'll also have twice as many decision trees. But that doesn't actually matter because we're allowed 50 nodes. We're not using nearly that many nodes. We can have more if we want. The important thing is decision trees don't cost money. Balancers cost money. So we put balancers in front to reduce the number of balancers that we need while keeping the same amount of processing power. So if we launch this one, let's go to the next day. See, now we're starting to make some money as users start coming in. So first week we were losing money, but now we are starting to get money. Okay, now the other thing is we are only able to process 407 users, and there are a lot of unprocessed users. But if you try to go back and double this up and put even more balancers, then it doesn't actually help. You're still not going to process enough users, and the balancers start costing money, which causes you to start losing money again. So I've experimented with that, and this seems to be the best you can do. Yeah, so even though there are users piling up and waiting for processing, I don't think we can do any better. So we're just gonna keep going until the profits are gone. Yeah, so this allows us to make profits for a long time. Okay, it's starting to die down a little bit. Okay, I think we're at the end here, and then we're going to cash it. Okay, so basically I think 2 lessons learned from that startup experiment. Number 1 is you want to put balancers in front so that you don't have to put extra balancers on multiple lanes. And number 2 is sometimes even if you duplicate the processing power, if you have to put too many balancers up front, it may not be worth it. So we'll keep that in mind for the next time we see a startup. That'll be it for this episode. I don't think I have anything else to say, so hope you enjoyed and see you next time.